Morning, everyone. Welcome to the speech. It's a pleasure to be here. And I would like to walk with you through a little bit of the technology part we are looking into, the hearing aid domain. Just a short, brief overview. So let's see what happened over the last decades in this field, and also why it is a challenge today to have complex DNNs, which we think is really the next step in the hearing aid industry. And for sure, giving a little bit of context in terms of what is required to do training. And nevertheless, what's important is the outcome of the technology, and I would at least give you a glimpse of what we have been seen with our testing. Okay, let's think about what we have seen over the last 4 decades in improving the SNR. So we want to improve speech intelligibility for our users. And if you think back a long time ago for me, so that was when there's only omni microphones taking up all the signals from every direction. Then going into some directional modes, a couple of years later, going into more automatic features. Going further on, digital with adaptive features, so even trying with directional microphones to do the next step. Going further, coming from 2 microphones to 4 microphones, so using the technology of a wireless link to communicate between 2 devices, make a narrower beam or go for a beam which is tending to the side to improve into that situation where the user is. But the question is then, that was 2010, 2012, and today it's an industry standard to say we are having binaural communication between the devices. We are using the same technology to get those beam patterns. But how to continue from here? Adding additional microphones into a hearing aid is nearly impossible. We have sometimes seen 3 microphones in the devices, but I think if you would think about Moore's law, 4 microphones, then 8, that isn't working. So there needs to be a technology jump. Just as a short reminder, directional microphones are really in the sense of suppressing the signal from the unwanted directions. And usually communication is coming from the front. And that is in normal situations where the hearing aid manufacturer put the directional beam. And it's really then taking out the signal from the back, assuming that there's no open coupling. So also the coupling plays quite a big role in what is the performance of the system. Just a short illustration of that. And we shouldn't forget, for comfort reasons, and also we tried out to see are noise cancelers a possibility to improve the speech intelligibility in difficult situations. We get comfort, but we don't see improvements in terms of speech intelligibility. So there have been a couple of studies trying to prove that there is more. So why is AI in the next part? So looking into the directional microphone, we see still improvements. So you can optimize algorithms, you can put the placement in different positions to really see that you get a little bit more. But is it really breaking up the paradigm where we are? So we might be at a technology limit at a certain point. That is what we are trying to see here with those 2 curves. So now we need to jump from one curve to the next and see how we can improve with this curve. AI has been becoming a big part in the last years. And we have more data to train. We have hardware which will become more efficient over the years, which will enable those use cases or future use cases in this field. So it's a technology which enables the new next steps. But why is it difficult to go into the field? So let's shortly remember a little bit. AI is not new. When we think about what happened over the time, it was somehow termed in the 1950s. There was a first big wave to say, hey, AI, that is something which is new, that could change our thinking and our possibilities. But after a first hype, it went down. So it's called summers and winters in this field. And there were some requirements missing, which we only got in the last 10 to 20 years. So more data is available. Think about all the internet, what is giving us the possibility to train networks, and for sure, there is more compute power available. Think about all the advancement in technology when it comes to having all the training for DNN GPUs, which we are calling needing for deep neural network training. That has advanced quite a bit since 2000 and enabling big jumps that we see take off. One of the major things were 1997, Kasparov beaten by a machine, later AlphaGo, and now we are talking about generative AI creating pictures and giving us text and feedback on questions we are asking. Let's look a little bit into the other field. So that was based on, we have enough compute to do anything. And also there we see limits. But looking into a hearing aid, we have a device which is very small, ideally worn in the ear sometimes, at least for such hardware, we need to think about what is behind the ear. We need to have a DNN structure which fits into the capabilities of the hearing aid. On the other side, it needs a specific knowledge about how to build that DNN to perform the task of denoising or beamforming or whatever we would like to see. And also, when you try to get a powerful DNN into a hearing aid, in the late years, there was no hardware out there which you could just buy from stock and say, okay, I take this, implement it, and can put it into the device and it works. So there's the implementation part, which was missing. The other critical factor for our hearing aids is processing delay. So always think about the 15 milliseconds maybe, which we are trying to see. Even Roger signals have a longer delay. They are around 24, 25 milliseconds. When it becomes longer, people perceive an echo. If you have open couplings and you are around 15 milliseconds in quiet environments, the sound becomes a little bit strange. So you need to see that the sound quality is still okay. So therefore, your target is in quiet environments to be even lower. So that's also the reason why sometimes signal processing is only enabled in specific conditions. And for sure, the question of, do we have enough training data? Are we really seeing all the world's generalization we need? So with the internet available, databases being made public with the possibility to generalize with the training. That was a question. I think it's now so proven that you can do it. You might not say performing well in every situation, but in most situations. And that is maybe also when it comes to this real life question. So in real life, it's always, or in the lab condition, that's easy to see, hey, it's working. A first prototype is often quickly built. But when you go out and try the device and see how it is really performing in the real world, you have different environments and different challenges. And you need to see that it really is performing also in this direction. And often the question is it only good for me, for one speaker? What happens if I have two speakers with similar voices? How is the performance overall? I have background music, I have only speech. So let's see how that really works and that it's really performing well. But we are coming into the area and see where is the benefit from a DNN. Not all the DNNs might be providing a good benefit. So with this graphic, try to see, we have a part where we say we need a certain computational power, and on the other side, we have a certain performance for denoising. Our current systems are doing in certain areas a quite good job, but that might not be sufficient. With the new technology, we are in this range of, yes, we get maybe in the rule-based system, but we need to learn how we get into a better performance area. So we need more computational power, and we need to have the right performance to be over the current technology. It's a bit different show of that. So looking back into the history, we have the question of power consumption. So on the x-axis and on the y-axis, what is the computational power you can create or get out of the system? On the top right, you have data centers. So very power consumption high, but on the other side, you get computational power, which is quite high. That is a study from 2019, I think, where we looked into what is available. And we need to get into a zone which is very low. So 2019, very low power was at 1 watt in this area. But where we are looking into is that we need to get into an area even below that to be applicable into a hearing aid. So how do you get there is then the question of having this zone we are looking for. So the Goldilocks zone is where computational power is required in the hearing instrument, about 10 milliwatts that you can really use for those operations. That was not available in the early parts. We see it took time to get there, and we will see more advancements in technology, which is helping us to go into that zone. So when we have all the ingredients to have a chip, let's see what is required to go into developing a DNN. So one thing is, it's an automatic process, or you want to make it an automated process, because there's a lot of iterations when it comes to rating sound quality or when it comes to judging the performance of a DNN. In order to do that, you need a good metric, as we call it, and such a metric you need to develop. So you can use technical metrics, which are maybe not the best in all the circumstances. In our case, if you want to go for a denoising case, you want to have people saying, hey, the noise suppression is good. On the other side, you want to know that the sound quality for the people is okay, and that the overall performance of the system is as you desire it. So you need to get those ratings, and as people do who are in the deep learning environment, they see it, they use the DNN as a tool to provide another tool. So with this information, we train a DNN, which is doing the estimation for us of those quality metrics. And with that, we can create new quality snippets of audio data, get them automatically rated, and have a performance measure of what the system is really doing. That's one of the ingredients to look further. The other side, we have the metrics. Now we need to think about what is the right structure. There's multiple types of mathematical operations out there to create a network. And now you need to find what is the optimal one to really go into the performance task. What we use for audio processing is a so-called unit structure. I'll spare you with the details, but we use a couple of those and see how to structure them differently to get to the best performance. In the second part, we use then the training of the model and say, okay, with those metrics we have developed, you are looking into improving the system over time, and this in an iterative way. And for sure, your hardware we have, or the hardware we have seen before, is always a question, how is it performance? We optimize hardware and software together to see that it really performs well. And if it's a standard hardware, you need to see that you get your mathematic or your solution approach so close that you get a best performing model or best performing hardware to be low in power consumption. In that part, if you have developed the models, you will test and verify them. And this is the automatic approach where we see this part of, we have a noisy input, we have a clean label, so we mix them artificially. We calculate the ideal ratio, what is the, our preferred outcome, and we can see what the network is doing, get that estimated, and use that feedback for our training purposes. What we use for this training is a lot of data. So when we think about what is required, you need a couple of million samples to come to a model which is really performing well. And with these audio samples, then you can go on and say, okay, different types of audio samples, different network architectures. There's not only maybe one, but you can combine also different models to come up with the final one. So with the final inference of what you would like to put into the product. Telling that, for sure, a hearing aid currently is not able to learn itself. So it's all one static inference. So having learning devices with large DNNs, that is not possible. For that, you need a GPU cluster, you need extra hardware to do that. So what we see is with large DNNs in the hearing aid, we can do the next step. And that is what has been released, and we also see now from other manufacturers going more into this direction. But what we have seen before was also the application of machine learning of DNNs in the field of classification. So looking at a holistic picture, so hearing also has a lot of impact on our social life or of the life of the people. So one thing is the audibility, and then we cover often speech intelligibility. So here we can see that with the DNN compared to what we have today, it is improved by 13% in dynamic listening situations. So in static ones, we can use beamforming, which is okay, but what are situations where this technology is not performing well? On the other side, we also have the question of what is the listening effort? So you can ask people in a subjective way, and there we see that people have reported around 3 dB improvement. So they have the same effort as being in a 3 dB better as an R condition. So what does it mean really for them? It's less stressful for the day, and that's also what we get from reports. So colleagues of mine, they report, hey, I'm not so stressed after a work day. I can really enjoy going out with friends in the evening. So this behavior is quite a different change. So in terms of what the technology can do, and that's what we are looking for. The other part is subjective measures are always interesting, but also let's look a little bit into the objective ones. So the FNIRS is measured, and we could show that there is a significant reduction of blood flow in the brain when it comes to looking at the listening effort. So also objectively, we can see that there's a benefit using such technology. And also on the cognitive well-being, we can see improvement. So looking into a digit span work test, we see that the people are having improved performance. With that, we would like to see more studies. That's clear. Where do we benefit? Which population group benefits more? To get further evidence on what the system can really do, and to see how we can improve the system over time. With that, let's also try to go a little bit away from what we have been seeing with the application only as a denoising part. First, it's not only about the hearing instrument. If you have an embedded device or an embedded chip, you can apply it to different devices as well. So here it's very important to think also about what is happening to Roger or other assistive devices. Speech enhancement and denoising is maybe one of the challenges we are looking into. That is one of where we had for sure the easiest task, and that is a major problem. That will continue to drive us to see where is possibilities to further enhance and how to steer that and combine it with the current technology. But also think about speaker extraction. It might be good to think sometimes about, hey, I only want to hear my voice. That could be for a phone use case. Think about Teams. You could say, I don't want to have all the background noise, but can do speaker extraction if I don't have a powerful hardware doing that for me. And on the other side, what could be very interesting in the future is to think about different amplification schemes. Today, our system is really based on wide dynamic range compression, which is a little bit older in what we have seen, but it's very mature. But what are models behind that which we can use to really derive the next part? Maybe it sounds completely different, but what is the benefit we could derive from that? Is it close to be developed? Maybe, but also there the question is, which kind of information we get and how to train those models. And what for sure continues is the whole question about scene identification. So what we call classification to steer the signal processing in the hearing instruments. So also think about more personalization. So today, a lot of assumptions are made during the training on when we manufacture, when we develop the hearing aid, but how is the life really for the individual persons? Can we put something more into it and come with the new available data to different solutions or modify the existing solution to even get a better personal match? What we shouldn't forget is it's not always about what is in the device itself. One of our main tools is the fitting software on one side, so setting the devices in the right way, and on the other side, what are apps which are used together with the devices or which are even not used with the device, but used for counseling. So there is also a lot of opportunity. So fitting software, there's all about data. Can we use the data which is generated? Can we improve what we have as a model behind and go for the next steps? Maybe that's not a big, powerful network, but that we see smaller networks over time which will improve the situation. Or the getting from a small step here from one algorithm part to another one on the other side. Also, what is the prediction of settings? Looking into the part of Amazon bookstore. If you have read that book, maybe it's also interesting to do that. So how is the community working? How can you benefit from settings others have created? Is that something you could apply? So how to bring together the user and empower them and see what can be the right setting in the future. This could be driven by the app. This could also be driven by the fitting software to implement it there. And we shouldn't forget a lot of things about using the AHI or using the devices is about knowledge. So chatbots, recommendations in daily life, when it becomes difficult, it's sometimes good to get some additional feedback if there are problems. So chatbots can also be used in such a direction with dedicated knowledge towards the field where the question is. So not something general like asking the internet, hey, how do I deal with that problem? But we really tuned to what we are seeing in our field of hearing. And here, example of what you can do in the fitting software. So in the upper part and the upper picture, we have our dome proposer. So fit and go solutions is always, we have assumptions. What is the acoustic coupling? With that acoustic coupling, we want to provide enough gain on one side, but on the other side, we also want to have the acceptance of the device. So on voice issues is a problem. So what is the right balance for that? This is based on initial settings, and over time we can now see, hey, what we have assumed is not really happening because the dome size is maybe chosen differently. It's not sitting as tight as we were thinking. It's maybe tighter. So with the data we get from the field, we now can update our model and say, okay, now we are even a better match. There will always be cases where our proposal is not the right one, but at least get a better understanding of that, and we can achieve a 10 to 15% increase in performance with the right suggestion, limiting the effort in changing a dome, adjusting the settings in the run or in the next session or during the first fit run. With that, I will just summarize what we can expect. So the hearing device technology, we see advancements now. First chip release with what has been brought to market with Infinio. Others for sure will follow. The trend we see on the chip market is that we get more implementation of AI capabilities into chips, and this will become more performant over time. There will be a couple of generations till we hopefully or might end at a saturation, but we are at the beginning of that curve. And for sure, the question is always, is it one big DNN? Do we can split the task in multiple smaller DNNs? So what is the right question we need to answer and where we can provide benefit? And for sure, getting into the performance issue, we will master more the technology, we will learn, we will see that we get the current consumption down, we will see that we implement it more efficiently, and therefore enable the other use cases, and see that the use cases we have today can have a longer or extended time. And also data models in the fitting software or in apps will increase. So collection of data and also using that data, having the allowance to use that data enables improving the product overall. And I think that is a very crucial part, that we really can use data, that we have the allowance, and that on the other side, we then can update the model on a regular basis to really get the latest performance out of it. And the other thing is generative AI with the chatbots going into that field of using what is there. It becomes more powerful now over time, and we will see different advancements and different possibilities, but it's not the need only to be driven from manufacturers, so we also need to see what others are implementing or providing. Our core job is not to develop maybe the app, but maybe combine it in a smart way with the knowledge we need to have, with the audiological knowledge, with the treatment, with the journey, that this can be an ecosystem of different manufacturers or different providers to get into the next step. Thank you.